Volunteer? Krista? Just a backup. Conclusion? Right, just action items. Yeah, okay, cool. All right, so Chris is going to be a second note taker. We got the blue sheet circulating. You going to do Java? Okay, so Joe's going to do Java. All right. All right, so this work group is quite new. We met once in Hawaii, and we had very little traffic on the list. So you can see, and we had to question whether to keep on going with the work group. So I mentioned the concern on the list, and thankfully we had more discussion on the list and actually some contribution. So I hope that we can get this momentum going and actually get work done. If not, we'll have to question this again. So, all right. So agenda. We really want to focus on the core protocol document. Hopefully, we'll adopt one or two merging into one. As we only have one milestone, so a draft. Right. Good. Yeah. All right. So we'll just move on forward. Who's presenting first? Let's see. Oh, agenda bashing. Do anyone want to bash the agenda? I know I changed it from what I posted on the list. I think. Yeah, I know. I'm going to go back there. Good point. Actually, I only have one item, so if anyone wants to bash the agenda. 3, 2, 1. Okay. So we'll move on to
Third one is mine.
all right, cool. The mic's up there. And I've got this pink plastic thing here. So we're supposed to inform the speaker to stay within the pink box on the floor. That's the pink box right there. Yeah. All right. Good.
Okay.
Stay in there. Don't get out. All right.
Hello? Okay. So my name is Elio Damaggio. I came up with a draft proposal for Webpush. Can we go on the next slide? The main scenario that was addressed by Martin's draft was notifications for web applications in a mobile browser. The idea was that in order to preserve power, you want to aggregate multiple streams of notification on the same connection, and then the user agent, usually a mobile browser, would effectively dispatch those notifications to.
Can you speak closer to the mic?
To individual web applications. Now, another as part of the charter for this group, many of the problems that browsers have on mobile platforms are very similar that applications have on generic embedded devices. Things like hello? Can you get? Okay. Hello? Is this one better? I'll hold the mic. Okay. I feel like a singer. Oh, okay. Okay. So, yeah, this is a lot better. So a lot of those concerns are present in IoT scenarios where effectively devices are receiving notifications or commands or messages in general from a cloud server, and they still are on intermittent connectivity. You want to save power from their radio subsystem, and also they might have
constrained power devices. In particular, the aggregation concern comes especially in a scenario that we call field gateways, where effectively there are devices that are aggregating notifications for a lot of the smaller devices that are connecting to it. Think about in connected home scenarios, you might have like many little devices that are connecting through a more powerful field gateway that effectively is mediating communications when you're going in the open internet, if you will. Those field gateways do not have the same constraints that the traditional IoT devices have. They do not have to run in 8K of RAM. They're usually much chunkier machines that are perfectly capable of using HTTP2 protocols and secure communications. To a certain extent, you usually want them to be secure, since you are not in a local network, but you're actually going in the public internet. Can we go on the next slide? So this is a flow diagram of Martin's proposal that was shared for the last meeting, and then it was successfully revised. The idea is that in here there's a box called device. In Martin's draft is called user agent. That one creates a registration with a push server that acts effectively as a broker for the delivery of notifications. And that comes back with effectively two resources. One, there is a registration. The other one is a subscribe resource. The subscribe resource is used to create subscriptions for all the web applications, or let's say in the IoT parlance, the downstream devices, so the smaller the individual receivers of the notifications. And in this case, the user agent would call a subscribe method on this URL to effectively create multiple subscriptions for this individual web applications or devices. After that, the user agent can monitor for those subscriptions by effectively issuing a monitor call on the registration resource. That would effectively create a channel from the push server that the push server can use to push all the notifications for all the subscriptions that are associated to that specific registration. The individual web application, or in our case the devices that have a subscription resource, they have to distribute a push URL that has been created contextually with the subscription to their respective application server, so that effectively that application server has the rights to contact them through the push server. You can think about that URL as effectively a claim token that gives the rights to send to that specific subscription. The application server then can use that URL to contact the push server to send one notification, and that notifications get delivered through the correct registration channel to the user agent. In Martin's draft, there is no the user agent is supposed to effectively dispatch the registrations from this unified aggregated channel to the correct web application or device when they have been received. Next slide, please. So we have like effectively three main pieces of feedback that they wanted to provide on this draft. The first is this notion of registration. In general, we believe that this relationship between the registration and all the subscriptions are effectively putting part of the topology description on the push server. If effectively the push server has to either remember or in some form manage the fact that a certain user agent is acting on behalf of a certain set of web application. In the IoT scenario, there will be one field gateway is managing a certain number of downstream devices. We believe that that is a effectively a burden on the push server to some extent, and in many cases, getting rid of the registration concept does not affect the main advantage of using a push server and aggregating all the notifications on the same channel. The main advantage of aggregation and of like saving battery and saving resources stems from the fact that there is an aggregated channel which is effectively the same TCP connection with the same credential and authentication characteristics, and not with the fact that there is effectively one notion that is aggregating multiple subscriptions. The other thing is that there are some scenarios where effectively this notion of a registration containing some subscriptions are not required, and still the protocol provides many useful things. In the IoT world, that would be a case where a device is connecting directly to the cloud without any field gateway in between. Other cases that make it interesting are when devices are effectively moving from one field gateway to another field gateway, and you do not want to effectively having the push server having to keep track of all these movements. This also has some implications on the reliability of notification delivery, and that is going to be discussed a little bit in the third piece of feedback, and I will basically want to postpone it for now. Can we go? Then the next piece of feedback is mostly about message expiration. We feel that the application servers should be allowed to effectively provide an explicit time to live or expiration time to each individual notifications. This is because sending notifications that are effectively stale to the end device is a waste of everybody's resources. Next slide. The final thing is the reliability of the delivery for notifications. We think that this is central because not only there are scenarios for this, not only in the mobile world, where effectively many notifications are not ephemeral. Not all notifications are things that pertains to something that is going to be stale in the next 5 seconds, but there could be things that have to be effectively be delivered for the next few days. In particular, there are certain applications that are not going to be opened independently. One of those scenarios are like news applications where they send you a breaking news. Those applications are actually leaning on the notifications for them to be opened. We cannot say that we cannot rely on the application being run to discover the fact that a notification was not delivered. It is very important that the notification is delivered reliably. If we leave this reliability on top, effectively on the shoulder of the application, what usually ends up happening is that the application on the device creates an individual channel to their own application server to act the specific notification. This is an incredible waste which effectively denies the fact of having a unified channel. So we really think that this is really important to have this notion of reliability cooked into the delivery protocol. So we basically have a proposed flow where effectively we remove the concept of registration and we introduce an explicit ACK on the part of the device to acknowledge each individual notification. This ACK can happen on the same connection on which the notification has been delivered, and not like on another one, removing a lot of the problems with the per app specific acknowledgement workarounds, I would say. So in this case, the device does not create a registration beforehand, but effectively just creates a set of subscriptions for each of these devices that is responsible for it. then it monitors in all of those subscriptions independently. Now, the independence here, the critical portion, is that while being monitored independently, that it still happens on the same connection to the push server. So it is true that in our protocol we have you have to issue multiple gets to effectively monitor the different subscriptions, but we're not adding any additional load to the browser, because it already has to remember all the subscription that is managing, so that there is not like an extra storage cost. We can also think about like a unique gesture where effectively you can monitor for multiple of these tokens at the same time. But in this case, the push server doesn't have to remember the fact that there is a registration concept or any grouping of this subscription at the server level. In the same way as in the previous proposal, this subscription push token is transmitted to the application server for the individual app, that then can be used by the application server to push a message. In here, you see that basically on the device side, when the message has been pushed, the device or the user agent has to acknowledge the fact that the push was received. Is actually the final device that should acknowledge that, and making sure that the notifications gets redelivered if something happens in spotty connections or something crashes or anything else like that. On the other side, once we have feedback, you also once we have like feedback from the device, we also need feedback from the push server to the application server, so that the application server knows when it has to resend the notification or not. Effectively, when the application server pushes a message, is able to specify if it wants feedback or not. If that is the case, it can monitor a specific channel where effectively it will receive receipts for all the notifications for which the delivery receipt was requested, and it will receive like a message if either the notification was delivered successfully or it expired on the server. This basically makes the application server able to ensure reliability in a much easier way, instead of having basically to do their own timeouts and retries and tracking all of those things. Also, everything happens on the same communication connection, so there is no power burden on the device side in order to implement these techniques. So we basically proposed these changes in our draft. We removed the registration concept by having only subscriptions. This basically simplifies the protocol flow, because there is one less resource to have to take care about, to take care of, and the push server doesn't have to maintain this relationship. This also simplifies scenarios where individual devices or web application are migrating across user agents or field gateways. We provide two methods for the user agent or the field gateway to request push messages. One is a request on the subscription resource, which effectively is using HTTP2 push to receive like a constant feed of notifications for all the subscriptions that are of interest, or that can the user agent or the field gateway can specify a wait time of 0, where effectively only the notifications that are present at that time in the push server are delivered. That is a very common scenario in some IoT scenarios, where effectively you do not want to keep a connection open for a long time and you have it stand up at regular intervals. We do not have aggregation anymore. I want to caveat this by saying that while we do not have an aggregated resource anymore, the aggregation on the connection can still happen by virtue of the HTTP2 multiplexing capabilities, and we do not have any more collapsing, meaning that we believe that given reliability, each notification has to be delivered unless explicitly allowed by the application server to be collapsed. There are we're definitely open to have some other collapsing mechanisms. Many famous ones are collapse keys or anything that's similar to that. Next slide, please. We add the requirement for the user agent or for the device to effectively acknowledge the delivery of the notification. This doesn't mean that the application server has this requirement anymore, but that allows effectively the delivery of reliable notifications. We also have a request message format that right now is in JSON. We will see why this is important. This is where you can specify your options for that specific notifications, the request receipt or time to live, and potentially other things if we wanted. There was a proposal for multicast or anything that basically requires some information targeted at the push server and not at the final web application or final subscription. There are still some open issues, of course. The response message format for the delivery receipt is not fully fledged. Right now, basically, what can be sent through the channel is either if the notification was successfully processed or if the notifications expired on the server. These are basically the two states. There are some other proprietary push servers that have effectively a way from the device and from a web application to effectively piggyback that channel to provide some kind of reply to that notification, and that could be something that can be explored, but we do not do anything like that right now. There are some details in the return of the push request when things are not supported by the server. For instance, if the time to leave exceed the storage limit, we do not want the push server to be on the hook to support anything. So what is the correct way for that negotiation are still open. And of course, the fact that we have a JSON message that impacts the encryption proposal that Martin has, so that's definitely still up. Yeah, we definitely have some open issues there. In general, we would really like to have.
Yeah, I think we'll get Martin to go through his slide, and then we can come back to this. Yeah.
Okay. So basically, we really want to have the first version of a draft by some next steps for a draft by the end of this meeting.
All right, cool. Thank you. So we'll get Martin to present his side, and then we'll
thank you.
Pull interest from the group. Yeah. Let me see. Not two the same one. Let me see. Well, give me 1 sec. I'm just playing the other one.
Yeah, most people here probably know me by now. So, Martin Thompson. I work for a company.
Yeah.
I'm just wondering what's targeted at me at this point. It is right there. All right. All right. So my goal with all of this is so that we can get through the sort of questions that Elio articulated and actually drive to some sort of conclusion on each one of them. I have a couple of extra ones. So Elio nominated the first one as being fairly high on the priority list. This is the whether you have a single registration or things. On the list, we talked about the split of a subscription into two separate resources. I know this was in your proposal as well. That one got some fairly favourable feedback. I'll go over that. I'll actually skip over payload formats when I get there because I think we need to talk about everything else before we get back to that. But then payload formats and encryption sort of have this unique relationship. And then again, the other issues that you raised. Funnily enough, these are, I think, the only issues that are really outstanding with the work that we have. This is, there are a couple of other things that have sort of come up over time, but generally speaking, at least for the people I've talked to on this one, they're quite happy to do this later or do this as an extension or something along those lines. The core thing that we want to get out of this is the ability for someone to deliver a push message and all the supporting infrastructure for that. None of the rest of that's really all that important. So let's go on. I think we have, oh, yeah. So the most important thing is we need to decide whether we do something in the core spec or whether or not this is something that can be done as an adjunct later. Do we need to have this hold us up, those sorts of things? I think this is pretty critical. And the next point was, oh yeah, and we're here to make decisions. Next. Okay, so this is the aggregation option as I see it. User agents created a registration and subscriptions are associated with that registration. And this is the way I described in the original draft because this is the only way that I ever considered this sort of thing. You use that single resource to do all of the sort of general maintenance work, and this is what the connection is associated with and all those sorts of other things. This suits a model very well where you have the delivery of messages go into a single bucket. Now what Elio's described is a case where you have messages delivered into multiple buckets and there's no aggregation function at the time of delivery. You have aggregation happen at the time someone decides to pull on all of those queues effectively. And so that's on the next slide, where you only create subscriptions. You have one fewer tier in the diagram, and as I say, you rely on the multiplexing stuff to make sure that everything ends up going over the one connection as opposed to, I want subscriptions to be cheap, so there's going to be potentially thousands of them, depending on needs. I don't know, the Google guys here probably actually have numbers on these sorts of things and can help us out. So I have a decision slide next, and this is essentially pros and cons of either side, arguments in favor of one or the other. Aggregation, it's a lot easier to get your messages because the server knows about all of your messages. You just have to say, hey, I want my messages, and you get your messages back. It's more efficient to start up. One of the things that I found with implementing this a few years ago was that it was a lot easier with something like this to repair transient network failures. If you have 1,000 subscriptions and you have to tell the server about them every time you lose the connection, that's a little awkward, and it turns out that connections drop actually all the time. The single greatest source of load, I think, on those machines was setting up new connections. The actual messages that you deliver, it's just in the noise, basically. And the point here is that aggregation happens at the connection anyway. So I have a slight preference for aggregation, but I'm not going to lie down in front of a truck if it turns out that that's what people want. Disaggregation, the UA maintains the state with respect to the subscriptions and their relation to each other. It's a little simpler, so there's no registration step. You don't have to worry about that. I think that's all there really is to say about that one. It means then that the push service doesn't have to worry about this relationship between all of the different ones. I'll point out that in some implementations it's possible, if you are using the single bucket delivery mechanism, you can implement the aggregation thing without actually having a database table on the server. In order to do this, you have some identifiers in some URLs or subscription IDs or whatever it is that you use, and it's not particularly problematic. So I don't know. I think I'd like to open the lines for people who have preferences and talk this one out. I think this is important, and it will drive a number of other decisions down the line. So please say your name.
So, Costin, working on Google, GCM.
You may want to come close to the mic, yeah.
Microphone. Hello, can you hear me now?
Yeah, that's good.
Oh, I guess so. Costin, working on Google, GCM. I have a slight preference for aggregation. It is pretty expensive to do the lookups with the second option. Yeah. And it will, I mean, given the numbers of subscriptions per device, it will be quite difficult to implement, I mean, you know, to scale it. But we can probably deal with disaggregation if necessary, but at additional costs.
Harald Alvestrand. Apologies for not having read the mailing list, so this may have been answered. In the disaggregated model, the token identifying the subscription and where to push is the same, right?
That's on the next slide, and we've had some discussion on that point, but it is separate from this discussion. Yes.
I think the reason I worry is that if it's the same, that's why I don't think they can be tagged entirely. If they are the same and there's no other authorization for reading, then anyone who can push messages to me can also read all my messages, and I don't like that.
Oh, yes. So that is a good point. I did separate these out, but if we go with the disaggregation option here, we have to make a particular decision on the next slide. But I think we can. I think people can understand that. The idea here being that you actually have to have one private resource that only the user agent knows, as well as the public subscription resources. Otherwise, you end up in a situation where, yeah, you can have that. If you have a situation where there are multiple people who can write to a subscription, then anyone with the ability to write to a subscription would have the ability to also read from a subscription, and that would not be good. And I think that was actually one of the reasons that Elio suggested that we split. Robbie.
Robbie Simpson. One other thought, and I haven't wrapped my head around whether or not I have a strong opinion on it, but in the aggregation scenario, you now have to have some logic that's going to be able to disaggregate that on the device, right? So I get essentially one resource now that I have to have some kind of application logic to chop it back up and send it where it needs to go effectively, right?
Yeah, so you're familiar with the push stuff in HTTP2, right? Mm-hmm. That is already necessary in either model. There's no advantage to either side of this. Either way, you end up with a server push coming from the server with an identifier for the subscription as the URL of the subscription resource in that push. And so at that point, it doesn't matter which one of these has actually triggered that. And it looks the same at that stage.
I'll admit I've only read through these drafts a couple times, so I may be missing something, but it seems to me like the push in the aggregated option would be a push of a resource that effectively contains a lot of things I'm interested in. No? No.
So in both cases, if someone writes to a particular subscription, that subscription is identified by a unique URL for that subscription, and a server push is generated for that URL with just the contents of the message. There's no aggregation in the sense of them, it's part of some greater document that's assembled up over all of the subscriptions for a given registration. There's none of that going on. It's just a single discrete, this is the resource that has now changed as a result of the push. Anyone else like to throw their oar in?
Do you want us to get the feedback?
I'm looking to you for guidance on how we resolve the problem. You want to speak more to that, Elio? we've had.
What kind of data?
Yeah,
What
do
other
we need?
kind of data would we need to make an informed decision? Are there experiments we can run? Are there prototypes we can write? What else is this merely an engineering design choice, or is there something that we could use to help us decide?
I personally think this is largely driven by an engineering design choice.
Does that choice have to be made right now, or can it be put off until we think we know more?
I'd like to know what it is that we need to know to make the decision.
I agree with that.
And I would like people to,
That's
in this
what
room.
my follow on, if that was the
Yeah.
if that was the case, I was going to ask, okay, well, what do you need to know? So.
Okay, so basically there is also like a little bit of the scenario. So this is not just an engineering decision. The thing is that, especially if you consider reliability, you're effectively saying that the push server is going to have to remember the specific messages that are targeted to the individual registrations or subscriptions. In that case, having effectively the subscription model would be implemented with the fact that the message is actually sent to a specific registration, so to a user agent, and to a certain, and the user agent, like Robbie was saying, it is on the hook to effectively do the dispatching to the subscription underneath. In the disaggregated view, that step is not required, and there is technically you could have a system on the device where there are like many processes that are listening to the different subscriptions independently. From a reliability point of view, that also means that on the server side, the different buckets that things are sent to are not associated to the user agent, but are actually associated to the final device, which basically means that if we want, we can provide actual separation between the things, so they can be stored in completely in independent places. They can have like those kind of features, and it's the scenario where those subscriptions can also be effectively recomposed in different ways. In the aggregation model, effectively the topology of registration to subscription is fixed at creation of the subscription, and it cannot be modified. In the disaggregated model, I could the individual subscription can effectively are aggregated dynamically every time that the user agent is listening for things. That allows flexibility in some of the scenarios that we are targeting. Now that said, in the aggregation scenario, we would just basically have to require the creation of multiple registrations. There's nobody that impedes that. But we feel that is actually adding a concept that we would much rather not have to add.
Oh yeah, that is a good piece of information.
Okay. I'm interested in hearing from anybody else in the room other than these two guys. Literally anyone, even if it's to say, I agree exactly with what that person said. And you have to convince me you actually understood what it was that they said.
So I might as well go back. The Chicago Cable Labs. Yeah. The Chicago Cable Labs. So this is one thing that we have actually been interested in and we started following. So I'm glad it's happening now. In terms of making, let me say, I don't have the enough intel to pick one right now, but in terms of the question that was asked, in terms of what is needed to make the decision for somebody else, I would say just a little bit of time to run both the scenarios through the use cases that we are looking at and see if we find any issue. That's all. And I wasn't able to do it because I just very recently started doing it. That's just my point of view, but I guess that would help me make a decision one way or the other.
I'm open to that if it means that you're going to be, an ongoing contributor and helping, which I like the sound of. Does that make any sense to you?
Yeah. So
Oh, hang on, let's see.
Can I ask a question? So what happens with disaggregation if the device is not connected? Because you do not know where to send it. So you don't know if the device is registered, is gone.
So in the disaggregated view is actually the subscription that is linked to the device. So effectively, the device creates a subscription, and that is the thing that is used to both receive and send. With the subscription split that Martin is going to talk about, we're going to make sure that there are no like security holes, that you get like both rights of listen and send at the same time. But that's a completely orthogonal discussion. But effectively, if it's the registration, the thing that you then, when you show up, you say, hey, I'm actually interested in registration 1, 2, 3, and this is the thing that I created. Instead of having it at the registration level with a subdivision, we effectively are saying, let's have the full power to each subscription, instead of the subscription being just a targeting mechanism for something that you're actually sending to a registration. And that, I think, comes most from the fact that we're coming from scenarios where the topology is probably less clear than the mobile browser and web app. Does this answer your question?
Please state your name every time you're at the mic.
Costin. So it answers the question. It's possible to do it this way, obviously. There is a use case where you have uninstalled application, for example, and developers typically want to know that that subscription is no longer valid. And it's a bit difficult to do it if you don't have push server knowing which apps are installed on the device or on the web browser, and to respond to reject some requests, accept some other requests. Because the fact that a user agent stops listening on a particular subscription needs to be taken into account to reject messages for that subscription, saying that application uninstalled.
We have a solution for that on the next slide.
Oh.
Yep.
So can we?
So I wanted to just have one final thing, and then I think we might continue. Going through this, I forgot one thing, and I just realized this when Ilya got up. If we do A, you can do D if you need to. If you do D, A is not really an option. Do you agree with that statement? I mean, it's bad. It's awkward to do D using A, but
to a certain extent, yes, but that requires more steps. Meaning that every subscription, in order to be independent, requires the creation of a registration and the creation of a subscription, instead of just creating one thing. So technically, yes, one is subsumed by the other. But that's because, like, adding something, it's...
So I think what I'm hearing is, first off, a request for a little more time for some people to run some use cases through it, which I think is completely reasonable. Second off, I think let's make sure that we've captured the sort of sub-arguments that we've had, the little pieces that you remembered, make sure those all get onto the list.
I'll make sure this gets there. And
yeah. I mean, do you think we have to do anything else other than that today?
Well, I was going to make a proposal with sticking with A until such time as we resolve the issue, so that we have something in place. But keep the issue open.
Let's keep that open for a week or two. Like, well, I'm trying to push him along so that we make progress. Okay, thank you.
Oh, great.
Yes, that was an action item. Make sure you capture his name. And could you come say your name again so that we can get it in the action items?
Show Christy a badge.
Darshak Thakur, Cable Labs. Oh, maybe I should probably shoot.
Yeah. Show Adam. Okay, that's good.
Thank you very much for that. Okay. Go ahead next.
So we had some discussion on the list on this one, and I think the general sense was that we wanted to go ahead with this. So Ilya suggested that we split the identification of a subscription resource into two. One URL identifier being used to talk to the user agent about that subscription, and the other one that is shared with application servers for delivering push messages. So the advantage of that being that you can use the user agent side of the subscription for doing all the sort of privileged operations that we're talking about. You can read on this side, you can delete on this side, you can do whatever operations we consider important with respect to subscriptions. And you can hand out the public side of this to all comers, and all they get to do is deliver messages to you. The disadvantage is that there's more resources and links and all those sorts of other things, but I can't really see that as being a particularly big impediment to this. So I'm going to suggest here that we do the split and take an action to write it up. But I'm seeing nodding heads and no real dissent. If anyone wants to dissent, feel free. That doesn't sound like dissent to me. That sounds like, yeah, but go ahead and do it. Yeah. All right, good. Next.
Do you want to go skip this one?
I just wanted to set the scene there. There's been a lot of discussions about the sort of things.
Sorry, by the way, for stuff where nobody really cares, we didn't have a conversation about it. That doesn't mean that, like, oh, we've got consensus over this, we can't revisit it. It just means, oh, this is the direction we're going to go for the moment. And as we get a little further along, if somebody has a strong opinion about it, we'll have a conversation again.
Absolutely. So there's been a lot of discussion about the sort of things that people want to add, and Ilya suggested that we might need to add some TTL fields and various other requesting receipt fields and all sorts of other things like this. The obvious thing to do is define some JSON and go ahead and do all of those sorts of things. The problem with that is that mucks with transported binary information. You pay some pretty serious overheads at that point.
You know exactly what I'm going to say, right?
I can predict, yeah.
This is Joe Hildebrand speaking from the floor mic, to be clear. You could always use CBOR for that.
And I will tell you what I think privately. My suggestion here is we need to understand all the other things before we actually finally resolve on this one. I have proposed an encryption format that makes using the payload kind of difficult, but it's also kind of nice in various ways. So I'd like to get back to this one. We've got a couple of slides on the other things first, and we'll come back to it. Encryption. This is where I'm going to break out to the other slide deck, which I am going to go through in probably double time, because we actually want to talk about this in HTTP, but yeah. Because we have a habit of doing these things. Next. YOY. This was one of the reasons for doing this work. We wanted something that was usable, something that web developers could get their heads around. And Jose is that thing. So we were looking at somehow making Jose part of, be able to use Jose within HTTP. That makes sense. And we decided that encrypting header fields was too tricky. So we decided to go ahead and do the content encoding thing, which is a feature in HTTP where you can say, I've got a particular payload. The payload of the message is transformed in a particular way. It doesn't talk about the headers. You don't have to worry about all those sorts of things. Negotiation mechanisms already defined. All these sorts of things are already in place. And so this was an easy thing to do. Next. Use cases, file storage. You've got some encrypted information. You want to put it on a server and you don't want the server to actually know what's in the file. Encrypt it. Next. Yes. All right. How? So next one. We started with JWE because obviously you don't want to invent something in JWE as almost an RFC, but it has a lot of optionality that doesn't really fit into the negotiation model in content encoding, accept encoding, all those sorts of other things. So we decided to make a profile, and we were pretty aggressive about this. So the next slide actually describes what. So there's lots of things in JWE that you can say, this value must be this, and this value must be this, and don't use this. And we got through the list and we threw everything out. Next slide. So there was nothing left, and all we were left was the section in the JWA, which is the actual algorithms draft for Jose. Section 5.3, which had the specific content encryption scheme that we chose, ASGCM. Why would you choose anything else at this point? Well, mainly because Char isn't actually specified. Well, actually, the CFRG has finished that, but anyway, this one's better deployed. And we looked at that and we said, hang on a second, RFC 5116 doesn't have all of the other stuff that we have to throw away, so we don't have to describe all of the stuff that we want to throw away, so we'll just take 5116. And we can tell a similar story about this if you start with CMS. Same story applies. Next. But we had a few extra things. So when you do content encoding, the expectation is that you are able to stream the message payload, process it in chunks. Jose doesn't do that. JWE doesn't do that without defining a new encryption format. I'm sure Mike's going to correct me at this point.
No, I'm not going to correct you about that. This is
Okay.
Mike Jones from Microsoft and one of the Jose editors, along with Joe. The ironic thing is GCM encryption doesn't support streaming.
Correct.
Because it's an authenticated encryption algorithm. And by definition, you must, for security reasons, either emit a correctly decrypted payload or nothing. So you must have the whole payload present, which is the opposite of streaming. That's a good thing from a security perspective. So at least if I was going to comment on the paragraph in draft Nottingham that says, you know, the following things are not amenable to streaming, the algorithm you chose isn't either.
Yeah, we at best get chunks out of it, right?
You what?
We at best are able to process something in chunks. You need an entire chunk in order to make any use of the information, which is what TLS does.
Sure, but then you're producing partial results. Go ahead, Richard.
So this mechanism, you get a chunk, you get a chunk, you get a chunk. Does each of those chunks have the authentication information with it?
Yeah.
So you can authenticate the chunk when you get it.
No.
Oh, sorry, this is Richard Barnes.
Truncation is possible, by the way.
So what you're avoiding with this is sending a header every time that describes the... You send the header at the top of the stream that describes the keying in the algorithm, and then you just do the same operation every time. And I assume you have some algorithmic generation of nonsense.
Yeah. Okay. We actually have to amend that. This was based on where TLS is up to, so the actual streaming thing that we came up with was basically take what TLS does and steal it.
Okay, I'm not going to belabor anything now. I will, now that I'm aware of this,
have a look at
take an action to read and maybe comment. Maybe Joe can do the same. And
yeah, so we'll take that to the list. It's too early to feel like this is a done deal in any way. So let's have that conversation. But we don't need to. We don't need to beat that horse here.
Exactly. I just wanted to raise the flag.
All right. Next. Oh, and this wasn't my use case, but it was raised that we wanted to use the same secret information to encrypt different messages, which means that you need some other source of randomness in order to make sure that you don't end up with the same key and nonce pairs used for messages, which is a little bit awkward, but that means there's some extra stuff that we had to do in order to make sure that we weren't reusing keys, because that is a very bad idea with GCM. AAD in general, I think, maybe, but certainly GCM. Next. So this is the structure that we ultimately came up with. You take some secret and some bit of randomness that is unique per message, and you get a unique per message key, and you feed that along with a record counter and some AAD, which is empty, into GCM. And that's what you use to either produce ciphertext or plain text, depending on which direction you're going. This is pretty straightforward stuff. We're using HKDF, which is what TLS 1.3 has, I think, chosen to do. I'm not sure that that's been completely confirmed yet, but there was pretty strong sense that we wanted to do that there as an extract expand in order to produce some reliable keying material. And that's pretty much it. You rinse and repeat.
So
this number goes up by 1 every record.
Regardless of what we do, this is going to need a relatively good amount
Thorough
of
review,
security review and involvement. So
there's some tweaks here from the TLS formula that mean that it's going to need some.
we changed one bit, therefore.
Therefore, yeah, lots of care. Hard head area at the moment, but this is essentially the shape of the thing that we're looking to describe. Can we go on? We have a number of key exchange options. You can simply say there is a key. It has this identifier. Go and find it yourself. Don't put the header field in. You can actually explicitly include the key in the message. That actually makes sense in a couple of scenarios. I've been working on something where that actually could turn out to be useful. Or you can use Diffie-Hellman and share an ephemeral in there if you know the recipient's public key. And then they do Diffie-Hellman, extract some secret, run that process, encrypt the message. It's pretty straightforward stuff. Next, examples. These are verifiable. I have code that generated these. There's not a lot to it, really. You can see there's a key ID. There are 2 header fields, one of which is mandatory, the other one which may or may not be present. And there's this salt parameter which contains some randomness that makes sure that if you use the same key across multiple messages, you don't end up with key or nonce collisions. And base64 URL for the win. Next. And there's some code. I'm only halfway through the second one, so don't use that.
You'll let us know when it's safe. On the list.
I believe that safety is something that we can't guarantee. Yes.
When you're willing to have us start to look at it.
Yeah. I've thus far only implemented HKDF. Turns out that's hard.
So, Mike, again, I'll ask the novice question because I'm new to this context. You're passing a secret key openly in the message. I assume the message as a whole is moving over a secured channel.
In the scenario where the secret key is traveling, it generally actually travels a different path to the message itself.
That wasn't what you showed on the screen.
No, in that particular example, that was just an example. In the scenarios that I have in mind, which are not fully formed yet, that, by the way, this working group wouldn't need to concern themselves with. We're only really concerned with Diffie-Hellman in this context. The meta information and the encrypted body travel separate paths.
Okay, I'll go offline.
But we can have that discussion.
So at some point, it probably makes sense to split some of those pieces out into extensions or something, if we can, so that we don't have to bog down in doing stuff that we aren't interested in doing here.
These are 0-0 drafts.
Totally fine with that. So let's make sure that we continue to focus the discussion down in places where we think we're going to be fruitful.
Yep. All right. I think that's the end of that one. If we go back to the other one now, we have covered that one. And you'll notice here I suggested we, again, continue the conversation before we come back and make any firm commitments on this one. I suspect people will want to see that there's been better analysis on the encryption stuff before we actually move on with that one. Next. Okay, so this is the TTL question. How long does the server retain a push message? Can applications request a maximum TTL? Costin advised me that a TTL of 0 is quite a desirable thing from a push service operator perspective. It allows for an excellent optimization where none of these things actually hit disk before they get pushed out to anyone. Do we need to establish some sort of expectations around what services will accept for the value. And I think Elio had a similar question for that one. And can we negotiate that if we absolutely can't agree on something? Next, please. So I think this is, I think I might retract this now, but I'm not sure. Never mind. So the idea is that the application server signals a TTL with their request. We had some list discussion on this, and I think we resolved on, I don't know if there's list discussion or not. I always lose track of these things. Prefer relative time, so I keep this message for 10 seconds and then throw it away. Rather than absolute time, because clock skew is like the enemy. It turns out the clock skew is the norm as well. And we talked about using some, I suggested that we use this timeout header that WebDAV defined. It's horrific, but it could be made to work.
I don't think we need to go
have any
quite
particular
that
opinion.
far to reuse things that have come before. If it
No,
makes
fits.
sense,
It
fine.
really
If
fits.
it doesn't,
It
then
really does fit. What's horrific about it is the syntax. But then again, it's an
we don't have
HTTP
to go
header. That's not
that far because HTTP headers are cheap.
Yeah. I'm down with that. I think a new header field is probably the right thing to do in this situation. It means that we can avoid the format question just that little bit longer. Does anyone, so I retract this and say this is really quite straightforward, I think, expressing the preference, that is. So do people have any opinions on this one?
Yeah, I just wanted, Miguel Garcia from Google. Yeah, we are already encouraging using TTL in all the possible implementations that we have, so actually having it already from the beginning would be really nice. If we could just say, yeah, go ahead instead of different, that would be.
So I think I proposed some semantics on the list for how we might interpret the timeout thing. If I define a TTL header that has a number in it, without all of the stuff that WebDAV had in it, with roughly the semantics that I described on the list, does anyone have a problem with that? And the semantics are basically any state that you might incur as a result of this request, throw away after this time, or I won't need it after this time, you may throw it away. I think was the semantic I was looking for.
The evil eye was casting was to see how many HTTP people were in the room. I don't see M not, but I do see Patrick hiding in the back there, who might know of such a header.
I went through the registry. That's how I found timeout. I mean, I went through the registry and went, yeah. That's I'm with Joe on this one. I can make it shorter as well. I'm sure everyone will like that. Yeah. T. No one's taken that yet. Single character header fields are the best. Oh yeah, yeah. We want to be more like SIP. Yeah.
All right. Next.
There are some other things. So services will actually have a maximum TTL. I'm talking to the guys who operate our service, and they're like, well, we could do an hour, but if we have to do more than that, it's going to start costing us money, and they don't like that. I'm told that Google maintains theirs for 4 weeks. Maybe they have more money than we do. I don't know. The question is, what do we want to do here? Do we want to require some sort of minimum on this value so that we can sort this out, or do we want to have some way for the user agent to learn this? Because when you can learn this information, you can make this decision here, which is, I've been away for 4 weeks. Google doesn't retain messages for 4 weeks. I've missed some. Might want to start from scratch again. Don't worry about incremental updates to emails and all those sorts of other things. I'm just going to assume that I don't have any state and do a full resync or whatever it is that your application does in that situation. Pretend that you've been off on an extended vacation. And, you know, if it's the Mozilla one, I've been away for an hour. Oh no, I've lost state. That might be less than ideal. But does this make sense to people? Do they understand the sort of problem here? Do we need to build a mechanism to support discovering this? Do we need to specify a minimum?
Matt Miller. I would say it is very helpful when applications can figure this out. If we all agreed on a single value, great. If we can't agree on a single value, there needs to be a way to do it. But I think there might be bigger problems to solve first, but it's something that would need to be there.
So I'm just, you know, operating on the fly here. I could use the TTL header that we were talking about in the last slide to signal that.
If you're defining a new header, you can define whatever the
yeah.
semantics are in both directions.
I know that will make Mark sad, guaranteed. Yeah, yeah. Just a little part dies every time.
Luckily, we'll talk about that on the list where you can express your sadness.
They're cheap, is basically what I'm going to say.
And I think that's the right way to do it. Yeah.
That was Adam from the.
Elio.
This is Elio. So, Elio Damaggio. Basically, this is definitely useful from the client. If you take a stance where the application server wants to guarantee that things are not lost, if you have feedback, that's also another way where effectively you do not have. Sometimes it might not be possible for the client to do things, meaning like the client might not have the power to say, hey, my push is gonna expire in 4 days, so I have to connect because maybe the phone is off or like there's something like that. While effectively the application server has the power, especially with the feedback proposal, to say, well, this message expired, and then hence I have to send it again.
Pat McManus. Mark really should be here for this. You're describing a lot of basically the same semantics we put into cache control, right? You know, yeah, and the syntax that goes around with it. It doesn't apply to the cache, but basically you could just substitute this in for everything you want to express, and I think you got it.
So the reason I didn't go with expires or max age or something along those lines here and suggest that originally was that when you pull that initial registration or the subscription, depending on which way we end up going on that one, you get a max age, but your interactions with that resource cease at that point.
Right.
And then you start using it, and it's active, and you're active, and 4 weeks later, boom, it's gone. So that unfortunately ties the lifetime of the registration or subscription to this message retention interval, which I would hope is significantly shorter than the registration lifetime. And that was the thing that I was struggling with when I thought about that one. Yes, cache control was my first thought. So, yeah. So we need something more again. What Adam said. All right. And this is the last one, mercifully. End-to-end reliability is much easier if you actually know that the message got there and you have a positive confirmation. Talking about this with people at lunchtime, the sense was that you would want to make sure that the message had gone all the way up to the application and the application had given a positive signal. And that means in the Webpush context, it means message goes to the push service, message goes to the device that's running the user agent, goes to the browser, goes to the application running in the browser. The application running in the browser says, yes, I'm done, and then it goes all the way back again. So you have sort of full end-to-end reliability of message delivery.
Dan Drutza, AT&T. Actually, this is even more important for message suppression. When the message was delivered, if you subscribe to multiple devices, you don't want the same message to show up multiple times. So I think the receipt is important, and you probably want to tie it to the time to live to kind of determine, but as you said, it's an application-specific choice. Thank you.
Yeah. So I think this is, some people don't rely on this extensively, but others do, and I think this is probably something that we need to consider.
So what I just
more
heard,
seriously.
though, was that the user actually saw it effectively. The best you can tell was part of it, so that you could send
Eyes
the
on
receipt to
is
the other
not
side.
what we're looking for at this
Okay.
point. There's no eyes. It's the application. So the message has been delivered to the actual intended recipient, which is not a user in this context. It's the application running in a browser, or in the generic context, it's the application running on your phone that's using the notification service.
So there's two use cases. One was guaranteed delivery. The other one was message suppression. They're both relying on a confirmation from the server.
Yeah.
Finding a slightly different way of saying message suppression might get people more excited about your use case. Just look for a synonym.
So the example there,
because I understand what you're saying, but
yeah,
not everybody might.
So the example there is where you have multiple devices and you send the same notification to multiple devices, and you want to make sure that when one of them sees it, the others
Message
know to suppress whatever
deduplication
notifications.
suppression.
Yeah.
Deduplication makes lots of sense.
Message suppression, yeah, that is pretty good, isn't it? It's got a Newspeak ring to it.
But, Dave Robin, now you have confused eyes on with positive delivery. When you talk about message notification suppression, you're talking about eyes on issue.
Which is why I brought up eyes on in response to his.
Right.
Yes.
Yeah, which is why Dan, I think, tried to clarify that. We're talking here about delivery.
Yeah.
Any suppression that has to happen is an over-the-top thing that would rely on more push messages being sent to
Kill
those
everything that
devices
I've
and all
seen
sorts of things.
already,
Yeah.
that I know was delivered successfully already.
Yeah, and in those situations, a user actually does dismiss the notification here, and that requires that they go back to the application server and say, I've seen it, and then the message goes out to all the other devices in that set of devices and says, you can close the notification, don't bother showing it anymore.
Hi, this is Elio again. So to clarify this some more, when we say like to the application, that effectively means that the application on the web application in case of the browser has the freedom to effectively acknowledge the app whenever it wants. If it wants to wait that something has been tapped or clicked or whatever, that they can do that. But if they want to just say, hey, I just displayed something, or I did what I had to do, and acknowledge right away, they can. We basically, in my proposal at least, the scenarios that I had in mind was when the final application has a chance to say, I did all the processing that I wanted to do with this specific piece of information, and that is actually up to the application.
Miguel Garcia. So one thing that we would like to decide is the reliability of these receipts. Like it seems it requires a connection established by the app server, and it would be hard for us to like store this until they connect again if they are not connected. So I know it's a kind of a chicken and egg problem, but it's an actual thing.
Yeah, so what you need to do in this situation is you've got this one-way message that you sent to the user agent, and you effectively want a message to come back from the user agent all the way back up to the application server. And that's another one-way message, so that needs an acknowledgement as well. And then that's a one-way message, so you see totals all the way down, basically. I've talked about this one, I talked about this with Elio when we discussed this earlier, and I think the conclusion was best effort. You would at the application server, if you didn't see an acknowledgement within a reasonable amount of time, would try again. And if it happened that you delivered two messages and because you just missed the acknowledgement, well, you need to do some deduplication. But that's not a big deal. Yeah.
Harald Alvestrand, in the figure of the delivery receipt given by this guy earlier, I was struck by the fact that the delivery of the delivery receipt looked exactly like a push.
Yes, intentionally.
And in that case, it seems to me that this is something that can only be done competently at the application layer. There's no particular advantage in adding mechanisms at lower layers, so we can leave it at the application layer. That is, don't include any special mechanism for it.
You might want to answer that.
Well, I do not this is Elio. I do not understand how that could be done at the application level without having the push server in between. And once we have the push server in between, we're basically specifying how that feedback is going to be delivered. If it's done completely at the application level, that effectively means that the device will effectively have to create a connection for the purpose of acknowledgement, and in general that is very wasteful. And it's true that many messages might not require that acknowledgement. In that case, at least in our proposal, you can send a push without requiring a delivery receipt, so that is not required, and that connection is not necessary. But if you want to do it, the workaround that is usually done in mobile applications is that you have you open a connection to your server from the device, incurring all the penalty of TLS and authentication and new connection and everything else from your app to your application server.
Yeah, so that's actually a good point that I didn't really cover, is that it is possible, easily possible, to do this without building a mechanism into Webpush protocol or push service or anything like that. But those costs are significant. And the question that I think we'll need to answer now, and I think I have it on a subsequent slide, possibly the next one even. Let's skip this. We know how to make this work. No, I didn't have it. The question is whether we do this as part of the immediate work that we're doing in the core specification, or we decide to do it as an extension on that specification.
Receipt in general?
Just delivery receipts in general. Does Elio, who seems to care greatly about this thing, does he write a separate draft and we pursue that separately to the other work? And that's really the question that I think we need to answer, because I think that ultimately we will end up doing this, but it's a staging problem.
This is Elio. I think that again, to answer this question, we need to understand what scenarios we're trying to target, because there are in the mobile notification space and in browser notifications, you might want to target things that are effectively, let's say, real-time applications. So each notification is it's effectively ephemeral, something that's going to last in value in the last 5 seconds. You're animating something, you're providing updates on live updates on a web page, those kind of things where reliability is not a problem. My experience with mobile push notifications, not even the devices scenarios that I care about right now, is that usually you care about reliability a lot, most because the notifications are used to drive engagement with your app. And that's something your app is never going to be on again if you're not able to send that notification. So for you, knowing the fact that somebody is received the notification and avoiding duplicates and making sure that that piece of information reliably appears on somebody's phone is really, really important. This is why I care deeply about the reliability aspect.
Hi, Adam Roach. So, oh wow, that's quieter. So when I'm thinking through this and trying to figure out what the end state would look like if we did this as core, I'm sorry, we did this as not core, and then did it as an extension later, as an application developer, I'm afraid that what I'm going to end up with is I'm going to have this optimum way of doing things, and I'm going to have this fallback to things that are only doing core, and it's going to be really ugly. So because we know what this problem is, because we know what a solution is going to look like, I think we probably do it now.
That's a pretty convincing argument to me. Less convincing than Elio's, unfortunately. More convincing than Elio's. Yeah.
Yeah. Matt Miller, just plus one to what Adam said. And let's also remember that what we're talking about here are the bits. Applications are going to be doing other things. Making sure that we've got a delivery receipt That's not necessarily a read receipt. It's necessarily seen an eyeball. It's made it to the device, and we could tell that. Applications can deal with it from there. Let's make sure that we've got the primitives in place in the core.
And that's why we have meetings. I think that's great feedback.
Doug Turner. So I sort of disagreed. Basically, you know, as an app developer, you're going to send a push notification to a push server, and the device may or may not be on. If it's on, it's pretty easy to implement, delivery receipt for that. But if it's not connected, what are you going to do? In both cases, you know that your application will run at some point and will get that data. And so you have this back channel that you can use. There's a relationship between the app server and the application. So the app running will know that, hey, it's gotten a push notification, has all the data, and then using like existing technology, it could just, XHR back to the app server and say, yeah, I got all this. And so sort of by default, you do get delivery receipts. It's just not built into the push notification API, which makes things a lot easier to implement. I don't have to, when I build a push server, I don't have to remember these things. I don't have to also, making sure that the event gets all the way up the web stack to web content and the user somehow interacts with it. Very difficult to implement. So I would urge us to use the web, use the app and the app server and its back channel to provide delivery receipts.
Dan, with a little bit different opinion than Doug's. Yes, it's true. Eventually, you're going to launch the app and you're going to confirm. But the truth is that there are notifications that require confirmation immediately or in a short time, even if the app is not running. And if it becomes obsolete, at least for instance, you send a notification for some update or a news, and after that you don't need to send it anymore. You just ignore it. So the app server needs to know if it was delivered or not, so it can move on. And at that point, the interaction with the application doesn't matter anymore.
This is Eli again. Again, with the for the apps, I think that it's very unlikely. There are many apps, and notifications are used in a lot of scenarios where effectively the main point of the notifications is in order to get the user to open the app again. There are businesses built around this from many companies. That is really important. Saying that the app is going to be launched again sometimes, that's just not true, because that the notifications are used to drive the fact that you open the app. Some people use the notifications, think about your CNN apps or New York Times apps. You mostly look at the notifications and then you click them. An app is going to go in your not ever used app very easily if people do not have these notifications.
I wanted Miguel Garcia from Google.
And the Catalan.
I have 2 more slides. That one.
All right, when you say me, it's the combined draft, right? I mean, all of the...
We'll work something out.
So,
just me.
If you guys could get together and merge in sort of the best things, get a straw man together, that would be lovely. That makes the whole thing easy. Do you have a problem with that, or anybody have an issue with that? Yeah.
That's always been the intent here.
Good.
Clearly. So we just need to get some guidance from the working group on, I think, the aggregation one, which will drive the conclusion of that and a couple of other things. But aside from that, I think we have at least ways forward on the other ones. So it's you.
Yeah. Any other business?
Oh.
Yeah.
The authors are you going to put some combined proposals together? What's the next step?
What are we looking at for timeline? Can we get it out? within a month, 2 weeks, 3 weeks, 4
Don't
weeks?
say month. Someone needs to commit.
Okay.
So if you guys in
We'll
the
get back
next
to you
week
tomorrow.
could tell us, or tomorrow, give us a schedule for when you think you're going to have something, then we can start to manage toward that.
So do we have anyone in the room that's like, really upset about the way this thing is going? No? Okay, that's good. That's good to know. Right. So, all right. I think we're good?
Yes. Do you want me to do it?
I've done it already. So.
Thank you. So we have one more piece of business here, which is that Richard has been our intrepid leader for a couple of years now, and we would like him to come up, and we have just a little bit of a token of our appreciation for him. So, yeah. Imagine how hard it'll be after he uses our token of appreciation.
That's what I feel. Thank you very much.
Yeah, so a little round of applause for Richard. Thank you very much, Richard, for everything you've done for us. And with that, do you have anything else?
Nope.
Any other business?
Blue sheets?
Blue sheets, make sure you've signed them. Thank you, everybody. That's it.